multiplying, dividing algebraic fractions. But you know, for me, I love to see what we know as prior knowledge before we go into anything that seems new. So before we actually divide and multiply algebraic fractions, let's look at fractions that are very familiar to us. Let us try to divide fractions like these. So whenever we're dividing a fraction by a fraction, what is advised to do? We will keep the first fraction, we will change the sign of this operation, and we will flip or find the reciprocal of this fraction. So let's just write it down so we can remember. So we keep the first fraction, we change the sign to multiplication, and multiplication, and we find the reciprocal, or we could say flip. So we could actually use an acronym for these words. So we could say KCF, keep, change, flip. So whenever we're dividing a fraction by a fraction, that's what we always do. So we're going to go ahead and just do the instruction. What the instruction says. So we say we keep the first fraction, we change the sign to multiplication, we flip the second fraction. And because this is the way that this is the form that we always want the fractions to be. So when we're multiplying a fraction by a fraction, we don't have to do the keep, change, flip thing. We could just go ahead and multiply, or we could try to cancel first and then we multiply. So those are the two steps we can actually do to solve these fractions. We could actually cancel these fractions. We could actually cancel diagonally, or we cancel vertically. And how do we cancel? We cancel by using what we call the highest common factor of two numbers, the highest common factor. And what do we mean by highest common factor? If I'm going to cancel diagonally, so I'm going to cancel diagonally from this direction, then I would have to find a number, the highest number that can be divided into 2 and 4 without leaving any remainder. And just to give you a visual picture of what I'm saying, if I have 4 and I have 2, I want to find all the factors of 4. All the factors of 4 would be 4 can go into 4 one time, and 2 can go into 4 2 times. Then we'll do the same thing for 2. Let's just find all the factors of 2. Find all the numbers that can be divided into 2 without leaving any remainder. So 2 can go into 2 one time. So these are all the factors of 2 and all the factors of 4. But what are all the factors that they share? What are the factors that they share? And that's what we mean by common. What are all the factors that they have in common? They have 2, 2, 1. But which one is considered to be the higher one? So 2 would be the highest common factor, the higher common factor. So 2 is the highest common factor for 2 and 4. So whenever we multiplying fractions, we always try to see if we can cancel the fraction, whether diagonally from the left or coming from the right, or vertically over the left or the right. So we will cancelling this direction. So we will be cancelling by 2. So we say 2 divided by itself goes 1 time, 2 into 4 goes 2 times. And then once we would have found the highest common factor for 2 numbers as a fraction, the numerator and the denominator, then that fraction cannot be reduced any further, because you would have simplified the fraction in its lowest term. We can't go further. So we go elsewhere in this problem to see where we can cancel. Or if not, then we just go and multiply. So we could say, oh, there's a fraction. We could say 2 goes in itself 1 time and 2 goes in itself 1 time. And so we have 1. We can't multiply any further because we don't have any other numbers to cancel. So then when we can't cancel any further, then we do the multiplication. So we say 1 times 1 gives us 1, and 1 times 1 gives us 1. 1 divided by 1 gives us 1. And that's how we actually solve it. We could actually solve it another way. We could actually just go across and multiply the numbers. We could just say 1 times 4 gives us 4. 2 times 2 gives us 4. And 4 divided by itself gives us 1. So there are more than one approach to actually solve these fractions. But let us actually include letters now in our fraction. That is why it is called algebraic fractions. Alright, so let's look at it. Let's say 2 divided by a divided by 2. And since it is in this form where the fraction is dividing another fraction, we'll do the keep, change, flip. So we keep the first fraction, so we say a divided by 2. We change the sign to multiplication and we flip the fraction. So we can actually now either just go ahead and multiply across, or we could try to cancel. We could actually reduce the fraction before we actually multiply, because reducing the fraction help us to understand or to see the answer in a very simpler way than it being complex. It being complex, it actually, when you just see the fractions, you just multiply across, and then you have this big number in your answer. So to actually see what is actually, a smaller version of what you're seeing, we just try to simplify the fraction or cancel what can be cancelled, and then when it can't cancel any further, then we go ahead and multiply. So we could say a in itself goes 1 time, 2 in itself goes 1 time, and then we just say 1 times 1 gives us 1, 1 times 1 gives us 1, and then our final answer would be 1. Or we could actually do the other way to see if we would actually get the same answer. So we could just say, okay, we could just say let's look at it. Went back too far. So we could say a times 2 gives us 2a. A times 2 gives us 2a. So if we have 2a divided by itself, that gives us 1. Just as if we had two identical numbers being multiplied by themselves, that will give us 1. So 2a into 2a goes 1 time. So our answer will indeed be 1. Let's look at another one. What if we had 4x divided by 2 times, say, 16 divided by 8? Now, we could do the same thing. We could try to find the highest common factor of the fractions, and then we could cancel the fractions, and we actually get our answer. We could also just multiply across, and then we just try to reduce the fraction after doing that. Or we could actually do another way. We could actually solve this another way. We could actually try to expand the terms to see what are the terms, what are the factors of these terms that come together to give us these terms. For example, I could look at what actually makes up 4x. What makes up 4x would actually be, well, we could say 4 times x. So 4 times x is 4x, and we could say 2 times 1 gives us 1. We could also say what actually makes up 16. Well, we could say 4 times 4 makes up 16, or we could say 8 times 2 makes up 16. Or we could just do the same thing as for that. So we could actually now cancel all the commons that we are seeing in the numerator and the denominator. This is like finding the highest common factor. So actually canceling. So we could say 2 cancel 2. We could say 4 cancel 4 in itself goes 1 time. 4 into 8 goes 2 times. And then we could say 2 in itself goes 1 time, and 2 into 4 goes 2 times. And then we don't have anything else to cancel, so we could just go ahead and multiply. We could say 2 times x times 2. So 2 times x is 2x times 2, which is 4x. And then we'll have a 1 in this denominator. 1 times 1 will give us 1. So the answer will be 4x. Let's look at another one. What if I had 4x squared divided by 2x times, say, 10 over 7. Now, we could actually expand if we don't know how to divide a coefficient term with another coefficient term. then we could actually expand it. We could say what makes up 4x squared. We could say what makes up 4x is 4 times x times x. And we say 2 times x and equal to, we could say 2 times 5 divided by 7. Well, we could say, well, 7 is made up of 7 times 1. We could do that. But it doesn't really make any sense if we're actually dividing, multiplying, expanding a term, and we're going to use 1. Because, 1 is always understood, and anything you multiply by 1, it gives you back. Anything you divide by 1, it will give you back. So we could cancel. We could say now, x cancel x, 2 in itself goes 1, 2 in 4 goes 2 times. Do we have anything else where we can cancel? No, we can't. We don't have anything where we cancel. We just go ahead and multiply. 2 times x times 2 times 5. Let us take our time and deal with that. So let's look at it. So we say 2 times x gives us 2x. 2x times 2 gives us 4x. 4x times 5 gives us 20x. 1 times 7 gives us 7. 7 times 1 gives us 7. So the answer will be this. Let's look at another one. What if we had x raised to the 4th power times let's see, y to the 4th times z divided by z to the 2nd power times, let's say, x raised to the 6th power times y. Now we could do the same thing. We could actually expand the terms to see what actually makes up the terms, and then we just actually cancel. Or another way, we could actually perform some concepts of indices, where we can actually look at the common bases and we could actually subtract the powers. So we could actually say, if we have, let's say we have 4 x raised to the power 4 divided by that, it actually gives us, this will be cancelled out completely, and this will be left with x raised to the 2nd power, because the powers will be subtracting from themselves. So it's like you have 4 minus 2, it gives us a negative 2, but the fraction, there's a fraction already there, so we don't have to put a negative there because the fraction is already there. And we should go back to the laws of indices. We could actually look at it further. We could say we have x raised to the 1st power. This really is, if we should go back to the previous video that I made when we were introducing algebraic expression, we realize that any variable by itself has an exponent of 1 or as a power of 1. So since this term has an exponent of 4 and this term has an exponent of 1, then actually subtract the powers. If we are doing indices, common bases, and we subtract the powers, so yeah, actually this will cancel by itself, and this will cancel one of the powers and leaves us with y raised to the 3rd power. And for this, we're doing the same thing. So since this is z and this is z, we could subtract the powers, so we could actually say z is left and nothing is left for that. So finally, our answer will be, this is supposed to be a z, not a 2. So finally, the answer will be, if we should look, we are seeing that we have, we don't have anything over there, so we would say y raised to the 3rd power y raised to the 3rd power times 1 would give us y to the 3rd, x times 2x times x could give us y to the 2nd. But if this is not helping you, what we could actually do, we could just expand the fraction. We could actually expand the fraction to see if we get the same answer. So we can always expand the fraction. So let's expand the fraction. So what is really happening in the denominator? Let us see. We have x raised to the fourth power. So we have x times x times x times x. And y raised to the fourth power. So we have times y times y times y times y. So we have 4 identical y's being multiplied in the exponent form. So let's look at the denominator of that same fraction. So we'll draw our division line and we will say z times z. Now for the other fraction, we just only have z. And for the second, for the denominator, we have x 6 times. So we have x times x times x times x. How many x's? 4 x's. 1 times x times x. And then we just only have 1 y times y. So what we could do now is to cancel the common. So look at, so we say this x cancels that x, this x cancels that x, this x cancels that x, this x cancels that x. So we cancel all the x in the numerator in this fraction, leaving us with only 2 x's. Only 2 x's. Only 2. Let me see. Let me see how many x's I have. 1, 2, 3, 4, 5, 6. Right. So leaving us with only 2 x's. So these are the only x's that we have left. Let me point them out. Right. So we have this x left and this x left. So we have 2 x's, and now for the y's we have cancel that y with 1 y. So we only have 3 y's left here. So what we really have, this z cancels that z. So 1 1. So what we really have now is y times y, which is y raised to the third power. That's what I want. That was what I was trying to say to you. All right. So we have y raised to the third power times z, because y raised to, no, not z, times 1, because we had a 1 right here. A 1 is right here. So this y will be multiplied by that. So we have 3 raised to the y to the third power times 1 gives us y to the third power. And then now for, let us see what we have here. We have only z times, so we have now z times x to the second power. So that will be our answer. We actually got about the same thing. So we have doesn't matter how you turn it, whether x raised to the second power times c or z times x to the second power, it doesn't matter, because the law, the commutative property tells us that. Now let us look at another one. Say we have 4x over 5y times 3y divided by 8x. We could actually expand these fractions, or we could just cancel where we are. Now we could say x cancel x, and we say 4 into 7 goes 1 time, 4 into 8 goes 2 times. We can't cancel any further. We could say y cancel y, and then we will be left with 1 times 3 divided by 5 times 2, which is 10. Or we could do it the other way. We could actually expand the fractions. So we could say, we actually expand it. We could say, all right, let's say we have 4 times x divided by 5 times y times 3 times x divided by 8 times x times 8 times x, or we could even expand the 8 as well. We could say 4 times 2 times x. That will still give us 8x. So it doesn't matter, as long as it is in an equivalent form, then you will actually see you're getting back the same thing. So we could actually go ahead and cancel now. We could say 4 cancels 4, x cancels x, y cancels y. And now what we have is now everything. We should have a 1 there, 1 there, and we don't another 1 there. So what we have now is 1 times 3 gives us 3. 5 times 2 times 1, that will give us 10. So we got about the same answer. So let's look at another one. Let's look at this one. Say we have 4 divided by x minus 2 times x squared minus 2x all divided by 8. Now we could actually do this. So in a case like this, now we could actually do some factorization, and we could actually, break up the terms. So we could say 4 is the same thing as, we could say, we could do this, we don't have to, we could actually just factor this only, and then we could just go ahead and work about, we just want to see things very simply. So we could say 2 times 2 divided by x minus 1, because we can't do anything with that one. And we could say what can be factored in this numerator. The x can be factored out, and we'll have x minus 2 all divided by 4 times that. So what we never had to do that with, with these numbers. You could just left them we could have just left them just as they were. But we could cancel and cancel. So we have this cancel that. These are identical, so we can cancel them. We have this cancel that. Do we have anything else? Divided by 1, 1. Do we have anything else can cancel? But we could also cancel this 2 goes in itself 1 time, and this goes in itself 2 times. Do we have anything more that we can cancel? It doesn't seem so. So we say 1 times x gives us x, and we say 1 times 2 gives us 2.